Hey, hey, good night, everyone. So it's a bit late today. I'm Jack. I'm practicing leetCode problems with JavaScript. I want to get in Google. Maybe it's impossible, but I'm not good at algorithms, so I'm practicing every day. So yesterday we practiced. Yesterday we have finished the three of the problems: two sum, add two numbers, and longest substring without repeating characters. The last one cost us a lot of time, and still could not find out why our solution, which is literally the same with the official answer, but doesn't compete with other solutions. Of course, we are all using JavaScript, so it just suddenly recurred to me that maybe because we're using the literal map object, which is we used it as a hash map, but it might be not that fast. So I'll just made some changes, make some changes to this. Let map equals new map. I'll set get. Sorry, I forgot what the map is. So maybe what is it? Its map is should be add, right? Set map. Wait a minute. We just opened the console. Wow, this is a lot of errors on this code. New map. It should be add. There's get set. It's set. So sorry. So map. Wait a minute. It's map dot set I. And now you say map get sj and map get sj map set sj equals I. Yeah, let's submit. Wow. Yeah, you see that we just ran faster than 95% of JavaScript, and we improved the time, and maybe we can do it better. So it's just, wow, it's fantastic. Before we just you see that we just if you use object data rule, we just we are top 30%. Now we're top 5%. Wow, cool. Okay, so continuing for today, we're starting on problem 4, median of two sorted arrays. It is hard. Okay, let's read the question first. Okay, so it says there are two sorted arrays, nums1, nums2, sorted with size m and n. Find the median of the two sorted arrays. The overall runtime complexity should be O log m and n. Okay, you may assume nums1 and nums2 cannot be both empty. So one of them may be empty. So example, number 1, there are an array of 1, 3, another one is 2, so the median is 2.0. Why is it 2.0? It's because it's because 2.0. Why it's not 2? I think it's the same as 2, right? Okay, so next one is median of the sort array. So 1, 2, 3, 4. It should be 2 half of 2 plus 3. Median. So the median is the number in the middle, right? Find median sorted arrays. Okay, so let's make something clear. So what is median? So 1, 2, 3. the median should be 2. So the center one, the one in the middle. So 1, 2, 3, 4. There's no median, so it should be 2 and 3. So we take a half of it, so it should be 2.5. Yeah, it's cool. So now we are let's start working on it. The first thing that occurred to me is that these two arrays they may how to say, they may have some numbers which they may have some numbers crossing each other. What I mean is that if say we like 1, 4, 6, 7, and then we have 2, 6, 10, and we have, if we merge it, we will get 1, 2, 4, 6, 7, 10, and the median should be 5 and 6, so it should be 5.5. So the general brute force one, it should be, we should just merge them. We merge the two array, and then gets the median. How can we merge? But to merge, we we use 2 pointers, one I and j. We just merge the nums2 array into a new array. So we just compare. So it would be compare, and the traverse, it's not compare and, but traverse and compare. So it will cost us O m plus n, right? Because every number should be taken into comparison actually one time, which is not actually meaning that actually meets our needs. We need to O log m plus n. So this is not good. So this actually is not good, which we don't need to try it. If we want to try, it's very simple, I think. Maybe we should try that first. Okay. Okay, so let's first try them. Consts, we could the nums3. Yeah, and let I equals 0, j equals 0, I while let I equals 0, j equals 0, while I is smaller than we stop. Okay, was nums 1 length, or j, we will all stop at the end. No, we should loop through all the numbers, so we should end at nth, nums dot nth. So j is smaller than nums2 nth. While in each round we should Maybe a pop. Maybe we can use pop and pop. Wow, we could actually we use pop. Shift, yeah. Wow, nums1 dot length or nums2 dot length. Actually, if nums1 pop. Okay, yeah, wait. Const num1 equals nums1 shift. Const num2 equals nums1 shift. nums3 push math. Wait a minute. So if nums1 length equals 0, we nums3 push nums1, we push the rest of num2. Okay, if nums2 splice equals 0, empty. And if nums2 is empty, we do the same to nums1. And nums1 equals empty. If both of them have it, so we'll say oh shit, I made a mistake. So num1 equals nums1. We cannot use shift because we need to compare, not should use wow. Sorry, I made a mistake here. Wow, I is smaller than nums1 I length, or j is smaller than nums2 dot length. If nums1, if I is smaller than 1 dot length, no, we should if I is bigger is equals nums1 dot length. There's no more elements from nums1. We just pushes all the rest. Number 3 pushes nums2. Wait a minute. Anyway, we will just traverse all the main elements. So if there is no more number from nums1, we will just nums3 push nums2 j. plus. If j equals nums2 dot length, we use num3 push nums1 I plus plus. And if both of them are okay, if nums1 I is bigger than nums2 j, because it's bigger, so we nums3 push nums2 j plus plus. Else nums3 push nums1 I plus plus. So the I and j will break both they reach the ends of each array. So these nums should be okay. So if nums3 length mode 2 equals 1, so if it's odd number, we will just return nums3 num3 length so it should be, the median should be, so like the three numbers, we should be 1. So -1. Oh, what is -1 divided by 2. If not, if it is an even number, we should return nums3. If it is even, okay, it should be nums3 length divided by 2 plus nums3 length divided by 2 plus 1 -1. So this is the two numbers. Okay, I think I'm getting it right. Divided by 2. Yeah, let's submit. Oh, sorry. Nums3. Sorry. Oh, shit. Nums. Okay. What? Abort. JavaScript heat up of memory. Huh? Just run the code. Sorry, mate. We. Wow. Shit. If you, for 1 and 3, output is 22.5. Expected 2. Actually, for these two, so the first one we get j, because j equals length to, sorry, oh shit, oh no. So actually for the first round we found that is smaller than, never the 2, so we push 1. And next round will be 2 and 3, so we push 2. So it'll be 3 and the overflow. So J will be the nth, so we push number 1. So 1, 2, 3. So, and there are 3 numbers. So it should be 1, so we return nums nth minus 1. So it should be right. I don't know why. Maybe I made a mistake. I'll console log nums 3. Undefined. I didn't break. Sorry. I should use continue. Continue here. Yeah. Okay, so after 3 trial, we passed, but we didn't do good because it's only faster than 13%. 13%. Okay, we will make improvements. Current solution, we can see that it's O m plus n. We need to change it to n log n plus n. So what can we find? Let's look at the. Let's just take a longer example. Example 1 2 1. Anyway, 1 5 7 9 and 2 4 2 4 6 8 12. Okay, how can we find the median number? What's the rule? Let's say after merge there will be 8 numbers, right? So 8 numbers. 8 numbers. So the middle one is the medium. The middle 2 in the middle is the median number. This is the final result. Now let's say if this one where it is. So there are 3 numbers smaller than this one. So it cannot be only 3 smaller than this. So it cannot be 9 or 12 because there are already 3 smaller than them, and here smaller than them. And also for this number, it cannot be 1. Wait a minute. It cannot be let's make it change this one more to make these things stricter, more easier to see. 4 and this 10 numbers, so there should be 4 and 4, let's say. So there are 4 numbers smaller than this one. It cannot be wait a minute. It cannot be it should be. It cannot be smaller than there are 4 numbers smaller than this, so it cannot be 16. Sure. And this one, there are 4 smaller than it. It cannot be 2. Yeah. Hmm. Can we what can we see from this pattern? We find the median 1579. Focus. What if we take a look at first median and the second median? So it should be like this, right? 6O X and X O O X X. This is the median. Let's put it in this way. Put it in the generally the same order, like X O O X, and then we align the order like O. So if these, if this median is the same, so we are sure it's this. If it's the same, we if it's the same, is it? It just should be. Oh, this cannot be the same. if they are the same, like 2 3 2 3 2 3 2 3, then it should be 2 3. It's the same. Oh, yeah. If not, like something like this happen. This is the median, but this is the median, and we could throw half of it, right? Through this one, because it couldn't be in the median. For the median, there should be for a median there should be both the same amount of numbers, which is bigger than them, and small and or smaller than them. So for this group, they all had the same numbers, but it's for this one, since they are all smaller than them, actually there will be more numbers smaller than it than bigger than it. So we could throw this one, and at the same time we could throw this one, because if because they already have bigger numbers than it, and they will also have because this median is bigger than this median, so they will still have more numbers smaller than them than bigger than them. Actually, it's like kind of slide window. If we slide further, we can throw this part. And if it's this, like kind of like this, we can throw this part and this part. So why? Because the median should be always in the middle. If someone is kind of if the window is kind of bigger than another window, it means that the larger half will have both be larger, will be both larger in two of them, so they won't be in the median. So we can just kind of remove half of both for each time, until there are only certain fixed number of them, like 2 or 1. So in that time, the amount should be O log m plus n. Actually, log 2, right? Log 2 m plus n. So this is our solution. Let's do it. So at last, if median is found here, both them here, in one array or one in another, even the median is in this array or in another array, what's the condition of ending the loop? So in each round, we find the median of the both array and compare them. If one of them is smaller, we throw the smaller side and the larger side until there were only, like, say there were only 2 of them, and there's no way to Okay, there's still a way to throw them, right? Until there are two, like 1, 2, 3, 4. The median is 1.5, 2.5. So it's smaller. We just throw this away. This is 4, 5. Yeah. Or there's another case is that when throw and there's nothing, and there is something like this, then we can say this is the median. Okay, what is the case that or something like this, like 4, and we got 2, 5, 6, and we got this 4, and this is 3, so this is bigger than that. We will throw 2. If like this is 207, is bigger, so we throw half of them. What's the ending condition? If we throw 7 away, we will, well, this is the case. We throw 7, and then we compare 4 and 6. I find a problem is that we should throw we should throw the same amount of numbers at the same time. So for this case, we cannot throw any numbers. We just compare them. Right? There's no numbers to throw. Like if we throw 7, we need to throw 4. Which kind of is true. If it is 7 again, this is smaller, this is bigger, so we throw 7 and 7. We got 7 and 6. Oh yeah. So let's start coding. So after throwing them away, there will be only 1 or 2. So the ending condition is that while nums1's length is bigger than 1, or nums2's length is bigger than 1. And it gets the median. So how can I get the median is that, okay, const median 1 equals const median 1. Any good ways to get the median? The median should be let's define another function. Var get median of array equals function nums if nums length mode 2 equals 1, just return nums length minus 1 minus 2, else return nums nums length oh yeah, sorry, this should be the same. It's 3, sorry. 4 2 0 2, okay, plus nums length 2 minus 1, okay, so now we get median nums 1 const median 2 equal median nums 2. If median 1 is smaller than median 2, they could be the same. Oh, okay, so if median 1 equals median 2, we just return median 1. If median is smaller than median 2, then because it's smaller than like this, we will throw the median sum of this and sum of this. We will compare the amount. Okay, let's make it better like this. What is this? This is length. Yeah. Equal half count median 2 half count. So here we return this is median, and half count should be nums this one, and this one should be have to throw, so should be nums length minus 1. Okay, so if it is smaller than half count 1 and half count 2. If it is smaller than that, we should throw the minimum of half count 1 or and half count 2. So how can we throw them? Just use splice, right? nums1 splice I don't know if this just costs us more time, but we can just splice them. Sorry, it should be splice 0 and half count. Math mean half count 1, half count 2. nums2 splice. What is if I split 1? Yeah, it should be nums2 minus math mean this one. Else, if it's bigger, then they should be num1. If it is bigger, something like this, which is 2, and this is 1. And finally, we will have a situation that all of them is is bigger than 2. One of them is return equals to 1. If it be possible, because smaller than is this one, smaller than is this one. Okay. So now one of them is get one of the array become a single number, and then some is array. So how can we do now? This is the same, right? Because this is smaller than that. So we splice it with a mount. So actually we should say is equals than 0. But if this is only one number, the half amount will be 0. Is it safe to just throw all them away? It could not be the Yeah, because if one median is smaller than another median, this median cannot be the median. It should be something bigger than it. So the the, the, the should not have count, but cut number, cut count 1. Yeah, we just skip it to half count. Sorry. This should be. It should be +1 to include the number, and this should be, because it's a even number, so we cut half of them, not -1, but half of them. And now even for array of only one number, we can still remove them, right? And now if nums 1th, return, I don't like this one, so return get median nums 1, else return get median nums 2. So this should be working. Let's run some code. Maybe there are errors. Yeah. Oh, sorry. There's always errors. Oh, it's working. Maybe not here. Wrong answer. Wrong answer. It's 1, 2, 3, 4. 1, 2, 3, 4. Let's count some logs. 1, nums 2. Okay. So first 1, 2, 3, 4. And then we split 1 and 3, 4. Ah, shit. There may be a case that both of them are not empty. How? According to this one, we should 2 and 3. Still, there is. We cannot. We cannot. We can only medium. If this means then 2. Should be like this. We cannot remove 2, for this case 2 and 3. Cannot delete them all, so there must be some of them bigger, more than 1 elements that we can cut. So the ending cases should be 1 or 2. So if and nums 2 length return nums 1 1 0 plus nums2 0, get half of it, else return nums1 0 or nums2 0. Nums1 int return nums1 0, else return nums2 0. Yeah, this is cool. Output limit, huh? Output limit exceeded. Sorry, sorry. Shit. If this should be, I'm not very good. Come on, getting good Google. If nums1 length equals 0, we should return get median nums2, right? If nums2 length equals 0, we should return get median nums1. If not, if both of them are there should be return nums1 0 plus nums2 0 divided by 2. Run the code. We run this code. What? While length bigger than, so they failed. Okay, so here, oh, should be n. Yeah. What? So we stop here? Is 0? Okay, give me numbers 2. Shit. Wrong answer. Got 1 3 2. So actually it's bigger than 1, so they will stop at 1. But for 1 we can still remove half of them. So we end at So actually what's the condition we can continue? What we can continue is that it's bigger than 0. Or it's bigger than 0. No, because there will be a infinite loop for 0 and some array. What we allow is that there must be elements in both array. So it should be and there must be something we can sub. One, two, one, one. 1, 1 is not okay. 1, 2 is okay. 1, 3 is okay. So it should not be, it should be more than 2 of them. Yeah. Okay. Wrong answer. What? One, 2 minus 1, 3. So the median. Sorry. Oh. Median 1. Median 2. Half count 1. Count 2. Median is 0. Full median is 2. And because it's just more than it, it's bigger than it. So we splice half of it. So it is -1. For these kind of the actual middle is 1, 2. But how? It should be bigger than 4. Shit. If that's the case, there's something we need to fix, because bigger than 4. If bigger than 4, Now we can just say, actually, we can just merge these two array. How can I merge these two array? For because mm, mm, I just use some ifs. If nums1 nth, there's I think we better merge them, right? Okay, let's merge them. Mm. If we merge them or sort them, because we even sort we use it's for, so it's constant time. So we merge them. Okay, const nums3 equals nums1 concat nums2 sort, then we return get median nums3 0. Sorry. God. This is not right. Why? Why is -2? Hmm? Let's look at the question. Median is 2. Expect 1? numbers is string. A B A minus B. Shit. We cannot do that. We should minus bigger than 1, bigger than 1. And this should be minus 1. And here should be minus 1. Save to remove. It's safe to remove fewer numbers. Oh man, hate edge cases. Output limit exceeded. So it's 1. This one we can remove safely. Yeah. So it's just bigger than 2. Wrong answer. God, I'm gonna be crazy. We should just remove half of them because part of them might be the number. As few as possible. Wow, shit. I'm really bad at we are beating 70%. A into two parts at a random position. A has elements, so there are appliance of cutting, and we know length left A equals I, and left right A mi. With the same way, cut B into parts random position. If we ensure length left apart equals length right apart, then we divide all into two parts with equal length. The one part is always greater than the other. Then median left A, okay. Length F equals A, and okay. With the same way, B into random position left B, right B. Putting left A and B into one set. For right we need to be in another set. Let's name them left part and the right part. If we ensure they are the same length, max left part is smaller than mean right part. Then we divide all into two parts with equal length, and one part is always greater than the other. Then median equals max and mean. Yes, it's true, because if we keep the length same and max is more than this one, yeah, that's true. To ensure this condition, we just need to ensure I plus j equals m minus n plus nj. Yeah. So we all need to do is searching to find an object I, that bi's minus 1, bj minus 1 smaller than ai, and what is b and a? Okay. And a I minus 1 smaller than bj, where j, what? God, this is not that simple. Comparing the code, God. This one is too long. Okay, let's take it another 5 minutes to look at the explanation. Okay, if there will be into two parts, the equivalence and the one part is always greater. To ensure these conditions, we just need to ensure ij equals mi. Okay. Bij is smaller than is smaller than bj. Yeah. I said I no I think I know what happened. No, I'm not getting it. Okay. Searching I in M to find an object I such that bji is smaller than ai and ai is smaller than bj, where j equals I don't know what does this mean. Shit. Okay, they actually have good solution than mine. I need to understand this better, but that is all for today. Thank you for listening. Yeah, have a good night.